In the previous video, I gave you a bad explanation of why when you want to find out the limit of this, you can just concentrate on finding out the limit of f of x, and then whatever this limit is, you can then times it with a c. So I gave you a brief explanation that you could actually take the c out here. But in this video, I'm going to attempt my best to try and explain these other laws here for limits. Okay, but the proper way of writing this is actually like this. You see, you need to specify that as x tends to a, and then as x tends to a. You see, the limit of this as x tends to a. The limit of this is x tends to a. So basically, they all these are limits towards as x tends to a. But I just want to remove the clutter. So let's just leave it as this. But the proper way of doing it is actually like this. All these laws here, as x tends to a could be any point. But the thing is, let's just remove it so it looks neater. It removes the clutter. Okay, anyway, in this video I will try to attempt to explain this here. Okay, so well, in the previous video explained this. This video I will attempt to explain this one here. It's kind of, I guess you have to use your instinct here. Okay, so the second law, I guess, is this: if you're trying to find out a limit of one function, let's say for the time being adding another function. It could just be take away. It could be add or take away. But let's just say we've got one function here, add another. And remember, we are saying that this limit here exists and this limit here exists. The limit for f of g. Well, anyway, here if you look at this here, let's say this line here is f of x, and this line here is g of x. Now this function here, the black line here, well, let's just say at this point here it's a. Okay, let's just say that this here is 2, this here is 2, and let's just say this here is 3. Okay, when you try and create this function here, when you try and create this line here, 2 plus 3, that will take you to 5. Okay, so this point here is 5. If you look at this here, let's say this is 2.1. Say this point here is 2.1. Let's say this point here is 3.2. And then when you try and create this line here, you would simply get this, add this. So this point here is 5.3. My point is that when you try and create this line here, you are really getting whatever's here, add it to whatever's here to give you whatever should be here. So let's say you want to find out the limit of this black line here as x approaches a. Okay, so you need to consider from the left hand side, and you also need to consider the right hand side. Well, let's look at the limit of f of x here. Well, f of x here, the limit here, let's say is at 3. It approaches 3, and from the right hand side it approaches 3. Now the limit of g of x from the left hand side is 2, from the right hand side is also 2. So in a way, you see, when looking at this black line here, you would get this point, add this point to give you this point. Well, it turns out that the limit of f of x, well, I guess there's not much to explain here. It's more of your gut instinct here, because it's saying that the limit of this is 2, the limit of this is 2, and when you come to get this limit, add it to this limit, it will give you 5. And then looking at it from a different perspective, if you look at the black line in terms of a function where you get this function, add this function, you get this, and the limit of the combination of the two is going to be 5 as well. So my point, I guess you just got to use your gut instinct on this, and the same is true with this one here. Suppose you've got a function here, f of x here. You've got to use your gut instinct on this one. F of x here, and g of x is this line here. Now looking at it from this perspective, where you try and create the black line, well, to create the black line you would get this times this to create the black line. Now look at it from a limits perspective. Let's say as x approaches a here. Well, you could say that you can get this limit here, and then consider this limit here. Add the two together, it would give you this point as well. Or you can look at it from this perspective, where you've got a line here, and a line is this function at this function. The limit at a will be this point here. My point is that, well, to find out the limit of this here, you can't just find out the limit of f of x and then find out the limit of g of x and then multiply the two. So suppose this here is 2, this is 3. Looking at it from this perspective, well, to create this line here, I would get 2 times 3, which is 6. Now let's look at it from this perspective now. Well, the limit of f of x here, the limit of f of x as x approaches a is 3. Now let's look at this here. The limit of this will be 2. Well, the limit of, well, you can just get this times this with gut instinct. So you just got to use your gut instinct on this one. And the final one, you can use the same argument here. Oh, when you do this here, make sure that this here does not equal 0. Okay, this cannot be 0, otherwise it won't work. So make sure that this is true. G of x cannot be 0. The limit as x approaches a cannot be 0. So make sure that this bit is not 0. Well, let's look at it. The same, pretty much same argument here. Let's say you've got a function f of x here, and then you've got a function g of x. Now to create the combination of the two, remember the black line is a combination of the two. So this black line here is really f of x divided by g of x. And notice that g of x cannot be 0, so excluding the 0 here. Let's just say that the black line here represents f of x divided by g of x. Now let's just say this is a here. Now, well, if you're trying to find out the limit of this here, you can just get the limit of f of x divided by the limit of g of x, and that will also give you this point here. Yes, yeah, I guess you've got to use your gut feeling on this one, okay?